I'm going to make a series of 3 videos that deal with a brief review of factoring. Factoring is something that we're going to come back to on several occasions, so this is just a preliminary little reminder of how things work. So the first thing is, what is factoring? And what are we trying to accomplish? So the important thing to understand about factoring is that it's not only applicable in one context. It is the act of writing anything as a product of 2 or more other things. So to factor anything, so I'll just say to factor something, it could be a number, it could be a polynomial, is to write it as a product of 2 or more other things. And rather than just calling them other things, we call them factors. Okay, so for example, we all have experienced factoring in lots of ways, but here's an example, like the number 28. The number 28 is 4 times 7. Now, some of you might say, oh, but you can factor 4 down further. That's true. You can write it as 2 times 2 times 7. And that would actually be the farthest you can break 28 down. So there's more than one way to factor the number 28, but there's only one way to factor the number 28 in a way that the factors are all prime. If we look at a number like, say, 43, is prime. This is a relevant number, this is a relevant word when we're talking about the concept of factoring, because number or a polynomial that is prime is not possible to factor. It's not possible to write it as a product of 2 or more factors unless one of the factors is the number itself. So the only way to write the number 43 as a product is to write it as 43 times 1. So for our purposes right now, I want to talk about factoring polynomials. Okay, so polynomials are actually going to be a big topic of conversation for us later. So believe me, we'll be coming back to this. But I just want to say a few quick words about them now, and we will mention them in the next 2 videos as well. So the first thing about a polynomial is the degree of a polynomial. So the degree of a polynomial is the highest of the degrees of its terms. Okay, well, what does that mean? So, for example, say you have a polynomial like 7x minus 5. So you'll notice I'm not going into a ton of detail into what a polynomial is exactly. I'm okay with that sort of being a word that rings a bell for you because we'll talk a lot more about it later. So 7x minus 5, when we're talking about degree, we're looking at powers. So 7x minus 1, you could look at 7x as being 7 times x to the power 1. So we can say that the degree of this first term here is 1. And then 5 is a constant. So again, we'll talk more about this later, but you could almost imagine it as 5 times x to the power 0. So a constant is always degree 0. So since the 2 terms here are degree 1 and degree 0, the degree of the whole polynomial is 1. Incidentally, a degree 1 polynomial is also known as a linear polynomial. Okay, here's another example. Say we have 4x squared minus 6x plus 2. So if we're looking at the degrees of the terms, the power of x here is 2. The power of x here is 1. The power of x here is 0. And so if the degree of the whole polynomial is the highest of those numbers, this is a degree 2 polynomial. And degree 2 polynomials are also known as quadratics. Okay? Now you'll notice in these two examples that I wrote the polynomial with the terms going down in order by degree, and that is kind of the convention that we adopt. We usually use that method of writing terms, that we write the highest term out front, highest degree term out front, and so on down from there. It makes it much easier to tell what the degree is, and it's just a great organizing system. So what I want to say before we do a few examples in this first video is when factoring a polynomial, and this is a big deal, the degrees of the factors add to the degree of the product. Okay, so that seems like, okay, like why would that even matter? But you'll see why it's so important in this video a little bit, but even more so in future ones. So let's look at an example. And for this example and all of the ones after it, what we're going to do is we're going to focus on one factoring technique. We're going to focus on identify and factor out the greatest common factor. Okay, so that's abbreviated as GCF, and that's the greatest common factor. Okay, so we're going to look at a few examples here. So say we have 12x plus 18. Okay. So what are we looking for when we look for the greatest common factor? So we are looking for something, maybe a number, maybe a whole term, that is a factor of every single term of the polynomial. Now, if we were in class together, I would ask you to tell me what you think. So my terms are 12x and 18. So one of them is a constant, the other one of them has an x in it, which means our greatest common factor is not going to have a variable component because one of our factors doesn't have a variable. So we're really going to focus on the 12 and the 18. So I'm asking you to think about what numbers do both 12 and 18 go into? Well, 12 and 18 are both divisible by 2. They're both divisible by 3. Oh, if they're both divisible by 2 and by 3, they're both divisible by 6. And 6 is the largest number by which both 12 and 18 are divisible. So we're going to say here the GCF in this case is 6. Okay. So when I say factor out, you'll see here I said factor out the GCF. What am I referring to? Well, what that means is write your original polynomial as a product of the GCF and whatever else. Okay, so look, I'm going to write that 12x plus 18 is equal to 6 times something. Now this is where the degree statement that we made above becomes important. 12x plus 18 is a linear polynomial, and 6 is constant, so that means that its degree is 0. Since the degrees of the two factors have to add to the degree that we started with, this has to have degree 1, which means it'll probably have an x term, and it'll probably have a constant term. So let's think about the x term, right? Well, 6 times what would give you 12x? Oh, well, that's 2x. So that takes care of our x term. And then 6 times what would give us 18? That would be 3. A way to think about this that's a little bit more visual is to think of 12x plus 18 as the area of a rectangle. So you have some rectangle, and you know that the area of it, so the space that it takes up, is 12x plus 18. And then I'm telling you, okay, you know what? I'm going to break that rectangle. Like, I want you to tell me if one of the sides of the rectangle is 6, then what's the other side? And then you can sort of do this. Like, you've got your 12x and you've got your 18. So 6 times what is 12x? Oh, that's 2x. And then 6 times what is 18? That's 3. So in a sense, what you're doing is you're kind of doing the opposite of the distributive property. Let's do one more example before the end of this lesson. So we're going to do the same instructions. Identify and factor out the GCF. And say that our polynomial is 4x cubed minus 6x squared plus 10x, okay? So in this case, you'll notice that all 3 terms do have a variable piece, and what you'll hear me say a lot is all of them have at least an x. The last term is just x, the middle term is x squared, so kind of like x times x, and the first term is x times x times x. So every one of the variable components has at least one x in it, which means that if we're thinking about what do they have in common, they have one x in common. All right, so let's get to work identifying the GCF. So we know it has an x. That's looking at the variable piece of it. Now let's think about the constants. So my constants are 4, 6, and 10. Granted, one of them is -6, but that's not terribly important when we're talking about divisibility. What do 4, 6, and 10 all go into? Well, it turns out they're all divisible by 2, and that's it, right? 10 is 2 times 5, 6 is 2 times 3, and 4 is 2 times 2. So they have the 2 in common, but they don't have anything else. So the GCF here is 2x. Now from here, we're going to do the factoring out. And again, if you liked this sort of box drawing, I highly recommend that you use it. If you could do the factoring out in your head, wonderful. But I personally think visuals are a huge help and we don't give them enough credit. So I'm actually going to do the box. Or maybe I should be more precise. I'm going to do the rectangle. So I know that one side of my rectangle is the GCF, which is 2x. And then on the inside, I have 4x cubed. I have minus 6x squared. And I have positive 10x. So now I'm going to go one step at a time. And I'm going to ask the question, 2x times what? So I'm thinking about this first part here. 2x times what would make 4x cubed? Well, I need a 2 to make the 4 and x squared to make the x cubed. So 2x times 2x squared is 4x cubed. Now by that same token, 2x times what would make negative 6x squared? So that's minus 3x. And then last but not least, 2x times what would make 10x? Well, that's just 5. Okay, so notice that we are being careful about signs. Since we need the middle term to be minus 6x squared, we are saying it's going to be 2x times negative 3x. So signs are very important in the factoring part. So we have 2x times 2x squared minus 3x plus 5. In our next lesson, we're going to talk a little bit more about some other factoring techniques. So specifically, we're going to ask if you have a quadratic polynomial, so degree 2 polynomial. When is it possible to factor and how do we factor it? What are some techniques that we can use for that? And then actually in our last video, we're going to come back sort of to talking about the GCF. And we're going to bring up the possibility that maybe the greatest common factor is actually a polynomial itself. So it's not just a single term, as was the case with these two examples where the GCF was 6 or 2x. It's actually maybe something like x minus 7 or 3x plus 4. So we'll explore that a little bit in our last lesson on factoring, which is going to be on factoring by grouping. So keep an eye out for factoring reviews part 2 and 3. They are next.